Hello and welcome back to our course on creating virtual reality applications. This week we're going to cover the programming environments that we're going to be using. That's Unity 3D. So in this week, Unity 3D is our first topic, and then we're going to have a few more topics for the subsequent videos. Now, what is Unity 3D? Well, Unity 3D is a authoring tool for computer graphics applications, and it was especially written to create computer games. Now, when Unity was first developed, it wasn't actually developed to write virtual reality applications, or even more specifically, virtual reality games, but it was developed to write general computer graphics applications, and most people used it to create computer games. It was also actually used a lot in the scientific environment to create scientific applications that had nothing to do with games. So Unity's been around for a long time. And a few years ago, when the Oculus Rift came out, Unity and all these other authoring tool manufacturers, they added on virtual reality capabilities. Besides Unity, there are also other options that are better and worse in some ways than Unity, and I just want to make sure that you know about them. There's the Unreal Engine, Unreal Engine 4, or UE4. That's a very, very high-end computer game authoring tool. It creates beautiful graphics, and it's a really awesome tool. And then there's Lumberyard, which is also a game development environment, and Lumberyard is from Amazon. And for Lumberyard, Amazon has recently been adding virtual reality capabilities. So that's also a really good choice. Now I'll tell you a little bit about why I decided to use Unity in this course. So all of these application environments are called virtual reality authoring tools, or also you could call them virtual reality middleware, and you'll also hear the term virtual reality engine when it comes to these. So the advantages of these virtual reality engines, as opposed to writing your virtual reality environment from scratch in a programming language, which you could also do, especially if you've taken the second course of this certificate program, then you know how to write computer graphics applications in C++ with OpenGL, and you could do that for virtual reality applications too. So the advantages of these authoring tools are that you can develop your application much more quickly than if you were to write all the code from scratch. And that's because these authoring tool developers, they've thought about a lot of the things that you want to do. They added them as modules, and then in some cases you can just switch a button, and then you'll have a certain feature in there. Let's say, for instance, fog, or you're going to have a physics simulation that makes everything fall into the ground, lighting, shadows. A lot of these things are just checkboxes that you have to check, and then things happen that would otherwise take hours and hours of programming. So quick development is one advantage. And the other one is that you can program fairly efficiently, because they allow you to modularize your programs fairly well, so that you have little modules that you can reuse in other applications, or even in other places in your application that you're writing. And these modules are typically written in a scripting language. Disadvantages of using these authoring toolkits are that because it's such a high-level tool, you're losing access to the low level of the environment that you're programming for. So that could be OpenGL, or it could be even optimizations on the CPU level, CUDA programming, and such things. And the other disadvantage is that you're dependent on the provider of the toolkit to add new features that you need to support your applications. You also depend on the provider when it comes to hardware support. Say there's a new virtual reality headset coming out and you want to support it. If the provider of your toolkit doesn't actually support that device yet, then you won't be able to write software for it. So let's take a look at these three authoring toolkits and what their differences are. First, let's look at the Unreal Engine. The Unreal Engine has a learning curve that's a little bit steeper than the others, because you actually have to know a lot about how your scene is composited and how it's rendered and how you want to render it in order to even just show a relatively simple object on the screen. The benefit of that is, though, that once you have figured out how to do this, the Unreal Engine has an immensely powerful and capable rendering engine that allows for almost photorealistic rendering, better than the other two toolkits that I'm going to be talking about. So this photorealism is actually so important that a lot of games that are out there in the app stores, from the Oculus or the HTC Vive App Store, that use the Unreal Engine, they create amazingly realistic looking graphics. And that's a lot has to be credited to the Unreal Engine. Another benefit of the Unreal Engine is that it has fairly good VR device support. So all of your PC-based VR headsets like the Oculus Rift and the HTC Vive and the Microsoft mixed reality things, and all of that is supported, including even mobile virtual reality with your cell phone. The Unreal Engine is free to use for hobbyists, such as yourself. You probably are a developer who's starting in virtual reality. And the good thing is that you don't have to pay any licensing fees to the Unreal Engine, because you can just start using it, and then when you make a decent amount of profit, then you have to send them a little bit of your profit, a small percentage, to pay for the engine. I think that's a very fair approach. The Unreal Engine is also open source, which is great because it allows you to modify the code if you need to, and also to read the code if you need to, and need to figure out how something works. That can be important, especially when there is maybe a routine that you need to speed up because you need it to be faster for your application. And then finally, it's written in the language of C++, which is for game programmers pretty much the go-to language. You have a lot of control with C++ over what your computer does, over memory allocations, and so on. So those are all good things. Next, I want to talk about Lumberyard. Lumberyard is an Amazon product, and the VR support is slightly newer than for the Unreal Engine and Unity, which makes it so that there's not quite the same spectrum there, but they're getting there very rapidly. There are frequent updates of Lumberyard, and it's very, very soon Lumberyard is going to be on par with device support, I'm fairly certain. The other aspect of Lumberyard that's a real big pro is that it integrates the AWS cloud seamlessly. Of course, AWS cloud is an Amazon product as well. And the AWS cloud is very useful when it comes to applications that involve many users. So if you have an application that you want to involve many users that work together on something, it could be a collaborative game, for instance, then the AWS cloud integration allows you to seamlessly scale to large amounts of users. The Lumberyard system is also, just like the Unreal Engine, is free to use for hobbyists. It's also open source, and it's also implemented in C++ as well. And lastly, Unity 3D. Unity is the environment that we're using in our tutorial. Unity is easy to learn. I want to say easier than the other two. Part of it is that it's been around, the VR extensions have been around for longer. There's more material out there online at this point than for the other environments. It's very easy to add VR support. It also has absolutely great VR device support. Pretty much everything that's out there for virtual reality is supported by Unity. You can develop with Unity, you can develop even for augmented reality. The Microsoft HoloLens is supported. That also means that when you write an application in Unity, it'll run on all these devices, the Rift, the Vive, cell phones, whether Android or iOS, the HoloLens, all of those devices are supported. And just like the other two, it's free to use for hobbyists, and there's a reasonable fee that applies when you make a decent amount of profit. Unity, however, is closed source, so you're not able to modify the code. That also means that you can't read it. You can't find out what it does under the hood. And if you need for Unity to make any changes, then you have to contact the developers of Unity and hope that they're going to implement your changes. And then lastly, the way that you program scripts in Unity is done via JavaScript or C#. So there's no C++ option, which is for those of you who are game programmers and are used to C++, you probably will then use C#, which is fairly similar to C++, but it's not exactly the same. So you have to do a little bit of learning on that end. But on the other hand, those of you who are programmers for, let's say, web applications, you're going to be familiar with JavaScript, so you're going to have a really easy time writing scripts for Unity. So these three authoring tools are really the big ones out there, and they all support virtual reality that you do with mobile phones, as we do it in this course, in our tutorials, and also in the project that you're going to be doing. So this concludes our chapter on Unity, and in the next video we're going to talk more about mobile virtual reality.